Alright, hey y'all, it's Miss Summers. Sorry I can't be there today, some stuff came up, but I'm still here with you in spirit and in this nice little video to talk about ocean currents. So, thus far you should have already done your warm-up. I'm going to collect all your warm-ups from last week, the 2 days we were here, and the next 4 days. I'm going to collect those on Friday, so make sure you have those done. You watched a video on density, so with some water demonstrations that I showed y'all. Some water likes to sink to the bottom while other water likes to float on top, and why that is, and how that relates to what we're talking about today, which is ocean currents. Alright, so ocean currents, this is a picture off the coast of somewhere, probably off North Carolina it looks like. And you can see ocean currents, these little swirly patterns. Alright, these are movements of water. We want to know, why are they important? Like, why do living things need them? And also, how are they created? What mechanism drives this and makes it the way it is, and how does that affect us? So let's start with just a quick review of temperature, salinity, and density. Alright, so temperature affects water by heating it up and expanding it. So as you saw in the little demo, when I had water that was relatively warm, it was less dense because it's spread out, but it has the same mass. The density is lower. Colder water, that ice cold water, when you put it in there, is more dense, so that cold water wants to sink down to the bottom. Salinity, so sal, S-A-L, if you're taking Spanish or Latin, you know that means salt. Salinity is how much salt is dissolved in water. Where you have lower salinity, like fresh water, that is less dense because there is less stuff in it. Where you have higher salinity, so when I added a lot of salt to that water, because there's more mass, that makes it more dense. Alright, so that is how temperature and salinity affect density, and we'll get to why that's important to currents in just a few minutes. Alright, so let's apply. What will cold water do when it's put into warm water? Well, if you go back to your notes, cold water is more dense than warm, so cold water will sink. If you put fresh water into very salty water, fresh water, because it has less stuff, is less dense, which means it will float on top of that very, very salty water. All right. So let's move on to ocean currents and why they're important. Let's talk about what they are. So everything that you need to write is highlighted in red and underlined for your convenience. Ocean currents are masses of water that go from one place to another. Okay? So these are some examples. So the Alaska current, the California current, etc. They just move from one place to another. They can be on the surface, like these here, or they can be deep in the ocean. Ocean currents move water and more. So a neat way to study ocean currents is by looking at things that were not necessarily meant to be there, but got there by accident. So in 1992, here's this little story. This ship left from China. It was carrying just like a bunch of stuff, and it got caught in a hurricane, and one of the boxes, one of the big cargo thingies, fell overboard, and it broke open, and it happened to be carrying 30,000 rubber duckies. So if you can imagine what 30,000 rubber ducks look like, just all plopped out in the ocean all at once. And scientists use this as an opportunity to look at how all these currents are connected and see where all these little rubber duckies went. So some of them went along this current to South America. Some of them got caught on another current that washed up to Australia. And the coolest one, my favorite, about 10,000 of these rubber duckies got caught in this current that moved them up through the Bering Sea, in between North America and Asia. Russia's right there. Around the North Pole, and all the way back down into the Atlantic, down the Gulf Stream, and then up to England. So they ended up basically all around the world thanks to ocean currents. Alright, so the currents that move those little rubber duckies were called surface currents, and they move water horizontally along the ocean surface. These currents come from the wind. All right, wind is pushing this water to different places. And it's generally going to follow these sort of circular patterns. We don't need to really get into why that is, but just know that they do that. If I took a map of like wind patterns in the Pacific Ocean and put it on top of this one, it would be the exact same. Okay, so wind causes surface currents. And these currents, when you put them all together, make something called a gyre. Give you a second to write that down. Feel free to pause this anytime you need to write and you need me to stop talking. That's fine. If you know your stems, you know that GYR, gyre, refers to something like sort of circular or rotating, like a gyroscope. A gyre is a whirl of water, like a big circle, like imagine like a bathtub draining. That's a whirl. And it's caused by all these surface currents being put together. So we have the North Pacific, the South Pacific, the North Atlantic, South Atlantic, and Indian. Those are the main ones, okay? And you might notice on your note sheet, there's a little thing that says what you notice about the arrows, the color of the arrows. There's a couple patterns you might see, but there's only one I really super care about. If I look at all the red arrows, so imagine here's the equator, right there, that's the equator. All the red arrows, which are carrying warm water, follow the equator. That's where they start, and then they move away from the equator. So in the north, they move towards the North Pole, and in the south, they move to the South Pole. Wow, that's cool. And the cold, look at where the cold water starts. All right, here's cold water down by Antarctica. That makes sense. Here's cold water up north. That makes sense, too. The cold water is moving towards the equator. Is that a coincidence? Of course it's not. It's science, right? Ocean currents are needed to maintain the balance of heat energy. Okay, so basically, warm water moves from the equator to the poles. Cold water moves from the poles to the equators. And this sort of keeps everybody nice and moderate, all right? It keeps the areas in the poles get a little warmer because of it. Hey, thanks, that's nice. And the areas in the equator get a little cooler. Hey, thanks, that's nice too. All right? So that heat sort of balances out. That's the idea. And this is really important for climate. Give you a second to write what you need. All right, if we lived by a coastal area, we would see this a whole lot more. So the temperature of the current can affect the temperature of the places nearby. All right, so the Gulf Stream is a warm current, which is why it's colored red here. All right, hey, look, there's that too. Hey, look, reading. That's awesome. Here we are. Boop, 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 boop. There's North Carolina. Boop, 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 boop. All right, North Carolina is along this Gulf Stream, but this warm water goes all the way up through the Atlantic, sort of cuts in between, all the way up to the British Isles, which are right here, and a little bit up into like southern Scandinavia. Once you get up here, this line right here, y'all, that's the Arctic Circle. Like, it's really cold beyond this point. Like, it sucks. All right, but this warm water helps heat up and moderate the climate of this place here. So Stornoway, Stornoway, fancy. Stornoway is in Scotland. It's pretty high up in altitude, or not altitude, latitude. All right, it's above, if we like go straight over, boop, 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 that's northern Canada. That's pretty far up there. Like, Canada, I think about it as a cold place, but Scotland's not a cold place. Like, it's not super cold. It's not like super hot either. This warm water keeps it sort of warmer than this one. Hopedale, which is in northern Canada, you can see it's a tundra. It is super cold. The Labrador Current, which comes from up here, here's the cold water from the poles, moving towards the equator, brings us cold water, and it's always freezing here. All right, definitely know the Gulf Stream, though. Gulf Stream keeps us warm. Thanks, Gulf Stream. You're the best. Okay? All right. And you can see how currents affect temperature. So here in North Carolina, so the Gulf Stream sort of swipes by the this sort of middle part of the the Middle East, not Middle Eastern, that's not right. Blech, excuse me. These sort of Atlantic states over here. Here in North Carolina, temperature, it's about 40 degrees in January on the coast. You're not super warm. But if I go over on the same latitude, if you remember from the astronomy unit, the further inland you go, the more extreme your temperatures are. Being on the coast is a moderator because of those currents. Okay? All right, so enough about the surface currents. Surface currents are caused by wind. They help moderate climate. The subsurface or density currents are not horizontal. They are vertical, which means they go up and down within the ocean. And this happens as a result of density differences, which is why it's called a density current. So temperature, so this is why we talked about the demo earlier. Temperature can affect your water's density. Colder water will sink. And salinity will affect your density. More salty water will also sink. Near Antarctica, so if you look at this, this is a globe that you don't see very often. It's kind of a neat perspective. That's Antarctica right here. It's actually a lot smaller on maps than we usually show. That's Africa, South America, us, Australia, all those other cool people. All right, around Antarctica, because it's so cold and because of that, you have water that is super, 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 super dense, which means it sinks. Now, when it sinks, so imagine dropping like a big rock into like a glass of water. It's going to create a space as it sinks, and other water is going to come fill that space in, which is what happens in a density or subsurface current. This density is going to transfer heat around the world. All right, so super cold water is going to sink. It's going to travel. As it travels, it starts to heat up. It's going to rise back up. Now I have warmer water. That's all nice, fine, and dandy. Now it's sort of like a surface current. Now it comes back up north. Up, it gets really cold. It's going to sink back down again and make this big conveyor belt. All right. And again, all of this is because of the density of the water. So if I affect the density by either warming it up or making it less salty, making it more like fresh water, I can actually stop these from happening, which would be really bad. We don't want that to happen. Okay? So we talked about surface currents are caused by the wind and help moderate climate. Subsurface or density currents are caused by density changes in the water. And they also distribute heat around the earth, which is important. Now let's talk about one last thing. These currents can work together, and you have a phenomenon called upwelling, which is very important to ecosystems. All right. Upwelling is the rising of cold water from deeper layers to replace warm water. Now remember, cold water likes to sink. Cold water doesn't like to rise up. So you might be wondering, well, how does upwelling happen? Well, you have these winds, remember surface currents. Wind will push warm water out of the way, and it will give space for that cold water to come up. Now the reason cold water is important, cold water tends to have more nutrients in it. It is generally more oxygen rich, and there's just more stuff in it for living organisms. So where you have cold water, you're generally going to have more rich ecosystems. We need upwelling to happen to keep our oceans nice and healthy and to provide food for all the little critters in the ocean, all right? Those nutrients help feed the plankton, and then the plankton make the base of the food chains. In areas like in the middle of the ocean, like here, where you have like these random little islands, the cold water will actually get pushed up when it runs into the base of the island, and that's why you have these little reef systems, these little ecosystems forming. Is because all this nutrient-rich cold water comes up. Okay, so just quick recap. Why do I care about currents? I don't know why, because I told you to. No. Currents play a major role in climate patterns. They moderate climates. Warm currents will make some places warmer. Cold climates will make a place colder. It distributes heat. Currents help bring nutrients from the bottom of the ocean. So those deep currents, when cold water is sort of forced upwards, it carries some of those nutrients with it. And currents carry other stuff. All right, so it's not just water. human stuffs like garbage, refuse, whatever. All right, that stuff is going to be carried along those ocean currents. So something that, came from the other side of the world that somebody was careless about and, didn't dispose of properly can end up interrupting an ecosystem somewhere else. So it's important to be mindful of where stuff can end up. Okay, so those are our notes for today. I will make another video about the assignment. You will need your computer out for it. I will walk through some of the steps. It should be fairly straightforward. That assignment you will turn in, and I will see all of you wonderful people tomorrow. Okay, have a great day.